Antonio Project presents Inner Gas System Part 4, the flue gas.
Hello everyone, welcome back to my channel. This video is part 4 of inner gas system, which subject is the flue gas. Have you ever wondered what happens to the gases produced when fuels like coal, oil or natural gas are burned? Today we are diving into the world of flue gas. How flue gas is generated from triangle of fire to the gas composition. Understanding what it is, its composition, and what is connection of flue gas with inner gas system. Let's go to the animation video. Let's get started.
Fire triangle. Fire has been an essential element in human civilization, providing warmth, light, and a means to cook food. However, it is also a powerful and potentially destructive force. To understand how fire starts and how it can be controlled or extinguished, the concept of the fire triangle is crucial. The fire triangle is a model used to understand the elements necessary for a fire to ignite and sustain itself. It consists of three essential components. 1. Fuel. This is any material that can burn, such as wood, LPG, paper, gasoline, or fabric. Fuel provides the substance that undergoes combustion. The availability and amount of fuel determine the intensity and duration of a fire. Fires spread more easily when there is a continuous supply of fuel. 2. Oxygen or O2. Fire requires oxygen, typically from the air, to sustain the chemical reaction of combustion. Oxygen supports the oxidation process that keeps the fire burning. Oxygen is necessary to support combustion. In most cases, the air around us contains about 20.9% oxygen, which is sufficient to sustain a fire. Some fires, particularly in industrial settings, can be enhanced with pure oxygen oxidizing agents, increasing their intensity. 3. Heat, a source of ignition, such as a spark, flame, or high temperatures, is required to start the fire. It provides the energy needed to initiate the combustion process. Heat is the energy source that raises the temperature of a material to its ignition point. Different substances have different ignition temperatures, and the required heat can come from various sources, including open flames, electrical spark, friction, or chemical reactions. Once the ignition temperature is reached, combustion begins, and the fire sustains itself by producing further heat. When these three elements are present in the right proportion, a fire can start and continue to burn. The fire triangle is a fundamental concept in fire safety and prevention, helping to design strategies to control or extinguish fires. Understanding the fire triangle is crucial for fire prevention and safety. Firefighters use this knowledge to control and extinguish fires effectively. The fire triangle also has applications in industrial settings, where controlled combustion is used in processes like welding, metal cutting, and energy production. In these cases, understanding the balance of heat, fuel, and oxygen is essential for safety and efficiency. What is flue gas? A combustion reaction is a reaction in which a substance reacts with oxygen gas, releasing energy in the form of light and heat. Following is the types of combustions. 1. Complete combustion. Complete combustion occurs when there is sufficient oxygen to fully convert the fuel into carbon dioxide or CO2 and water or H2O. This process is more efficient and produces fewer pollutants compared to incomplete combustion. 2. Incomplete combustion. Incomplete combustion happens when there is insufficient oxygen, leading to the production of carbon monoxide or CO, soot, and unburned hydrocarbons. This type of combustion is less efficient and generates harmful emission. 3. Spontaneous combustion. Spontaneous combustion occurs when a material heats up due to internal reaction and ignites without an external flame or spark. This can happen with material like oily rags or coal piles. 4. Explosive combustion. Explosive combustion is a rapid reaction that results in a sudden release of energy, often accompanied by an explosion. This occurs in internal combustion engine and industrial explosions. The flue gas is the gas exiting to the atmosphere via a flue, which is a pipe or channel for conveying exhaust gases, as from a fireplace, diesel engine, furnace, boiler, or steam generator. Flue gas is another term for exhaust gas that is a byproduct of combustion. It is the result of burning natural gas, recovered natural gas, oil, coal, and other fuels in industrial equipment. Compositions of flue gas. This is the animation of fire tube boiler combustion chamber. Combustion chamber is where the mixture between fuel, air, and heat creates fire. Combustion occurs when a fuel combines with an oxidizer, usually oxygen, to produce heat, light, and various byproducts. The basic chemical reaction for hydrocarbon combustion is fuel plus oxygen create carbon dioxide and water plus heat. Combustion that burns fossil fuels or biomass processes generate various gases and particulates. Following is the composition of flue gas. 1. Carbon dioxide or CO2. As a primary greenhouse gas, CO2 is produced during the combustion of carbon-based fuels, such as coal, oil, and natural gas. It contributes significantly to global warming and climate change. 2. Nitrogen oxide or NOx. NOx gases are formed when nitrogen in the air react with oxygen at high temperatures. These gases contribute to smoke formation and acid rain and have adverse respiratory effect. 3. Sulfur dioxide or SO2. This gas is primarily produced from burning sulfur-containing fuels such as coal and oil. SO2 is a major cause of acid rain which harm ecosystems, corrodes infrastructure, and affect human health. Carbon monoxide or CO, an incomplete combustion product. CO is a colorless, odorless, and toxic gas that reduces oxygen delivery in the bloodstream, leading to serious health issues. 5. Water vapor or H2O. Water vapor is a common component of flue gas and plays a role in forming condensation and emissions plumes. 6. Particulate matter or PM. Fine particles in flue gas include soot, ash, and unburned fuel residues. These particles can pose serious health risks, including respiratory and cardiovascular diseases.
I think that's all my video about flue gas. Now that we have explored the concept of flue gas, we will learn how to use flue gas for inner gas in next part video. Keep monitor my channel to understand well about inner gas system. Thank you for joining in this discussion. Don't forget to click like, share, and subscribe button for more contents about maritime knowledge. See you in my next video. Bye-bye.
To create bonds between us, you can click on the subscribe and share buttons. Surely, Your subscription will fire up neutrons in my brain and boost my idea to create more educational videos with animation. Let's spend our time to study and take any positive energy to improve our knowledge.
Thank you for watching my video. Terima kasih di Antonio Project.